Hello, welcome to ELEC3844, Engineering Management and Society. Today's topic is risk management. When we operate a business or when you run an engineering project, you may encounter many different levels of risk. So you need to manage the risk and how we can accept, avoid, and share the risk to others. So risk management is an important topic and functions in an organization. So companies may take different levels of risk and we need to prepare for it. But do we need to avoid doing anything? Stay at home like what we are doing now to avoid all kinds of risks? Probably not. We need to also measure the consequence of risk. How expensive will the consequence be, and also whether it's too time consuming to rectify the problem, and what type of resources and the quantity of those resources that are required to avoid the risk. And finally, also whether this risk fatal, whether it's not recoverable. So these are also the factors that we need to consider when we deal with risk management. If there's some risks that are very serious, it's a disaster and it's not recoverable, then we need to prioritize those risks and maybe put more resources to avoid those risks and do some preventions. Just like this scenario, I believe that when you was young, you may play with this balance wood, and this little girl play with this balance wood without any safety measures. Compare with if you go to Macau tourist tower, you can pay some fee and then walk outside the canopy. But the width of the canopy may be a meter wide, and the width of this balance wood is just less than 10 centimeters. In terms of risk, perhaps walking on the balance wood may be more risky because it's easier to be fall down. In terms of risk, perhaps walking on the balance wood may be more risky because it is easier to fall down from the balance wood as the width is so narrow. However, the width of the canopy is much wider and it is not likely that you will fall down from the canopy compared with the balance wood. But the consequence of falling down from the Macau tourist tower will be very serious. Probably nobody can survive if anyone fall down from the tower without any safety measures. Therefore, in terms of the consequence, the risk impact of walking on the canopy in the Macau tourist tower is much more serious than walking on the balance wood. And therefore, even though this little girl walked on the wood without any safety measure, that's fine. The worst case is that she may fall down and may not even have any injury. Compared with this case, if anyone fall down, then there will be casualty. Therefore, we can draw a chart like this. On the x-axis is the impact of risk, and on the y-axis is the probability of the occurrence. So we can then measure and position different level of risk and the consequence. So in these quadrants, when the impact is low and the probability of occurrence is also low, then the risk level is very low. When both are higher, high impact, high probability, then this is a medium level risk. And when both impact and also the probability of occurrence are high, then these are critical risks. So the y-axis, the vertical axis, is defined as the probability. So how likely that this risk may occur, and for the x-axis is the impact of risk. It can be quantified by the size or human life or any cost in terms of the dollar sign. So this risk can be quantified by a number. So if we simply define the impact as low and high and the probability as low and high, then we can have four quadrants: A, B, C, and D. So in these four quadrants, we may have different attitudes and measures to deal with different scenarios. So in the quadrant A is those with high chance but the impact is low. For quadrant B, both the chances and the impact is low. In the quadrant C, the impact of this risk is high, but the probability that it may occur is low. And for quadrant D, this is critical. Both the probability and the impact are also high. Let's see this video to see how we can deal with different scenarios.
Actually, there is a way to look into your project future. It's called risk management. Risk management is a process that we perform on a daily basis. It consists of three main parts: risk identification, assessment, and control. Consider the following example. Imagine that you are walking in a hospital corridor and suddenly you see an electrical cable on the floor. Here you have identified a risk. You stop and think about the situation. Many people use this corridor, so there is a big chance someone will fall and injure him or herself. You need to do something about it. This is risk assessment. You go and talk to the man using the electrical cable, explaining to him the hazards of leaving it there in the hallway, and ask him to remove the cable or tape it to the ground securely. This is risk control. In that example, you saw into the future, the possibility that someone might fall over, and you did something to prevent it. Likewise, we could have anticipated that the crane might fail and prevented its failure in different ways, like say, maintenance. In this example, we went through a full cycle of risk management. We identified, assessed, and controlled the risk. Now let's examine these processes in greater detail. Risk identification is when we try to anticipate the future and think of possible events that can happen in our project and affect it in a negative way. In the project book, I explained two of the most important tools used to identify the largest amount of risk: brainstorming and the review of other planning templates. When identifying risks, make sure you invite experts in the technical field of the project, since they can uncover different risks they have learned from experience. Also, during risk identification, focus on generating a large number of ideas by encouraging people to participate. You don't need to assess their contribution at this stage. When you finish risk identification, you will generate a list that contains many possible risks that can happen during your project's life cycle. Chances are you will generate a long list of possible risks. But projects have limited resources, so we need to select the risks that are more critical from the list. After all, some risks are so small that they might not need our attention at all. Now we will start with risk assessment. But first, we need to understand the following 2 points. First, the risk formula. Basically, it says that risk depends on 2 factors: the chance of the event happening and its severity. So in the first example, the risk of a person tripping on the electrical cable is a combination of the chance that someone will walk in the corridor and trip on the cable and how big the injury will be. The formula will help you see basic components of risk and thus understand them and be more confident and objective when analyzing them. The second point you need to understand is the risk matrix. It's a tool designed to help you calculate the risk formula easily. It is basically a table where the chance that the risk will happen is indicated on one axis and the severity of the event is found on the other. The cells of the table represent the score of the risk, which you can define in many different ways. There are many different shapes of risk matrices, as discussed in the project book. So putting risk assessment into practice, let's rank the risk of the crane failure. We should ask 2 questions. First, what is the likelihood that the crane will fail? This will depend on the quality of the crane, how many times it failed in the past, and in what condition it is kept. So if it is fairly new and well maintained, the chance will be low. The second question is, if the crane fails, what effect will it have on the project? Well, this depends on the importance of the tasks which need to be done using the crane. So if we have a construction project with many lifting activities, we can rank the severity as high because many tasks will not be done if it fails. Important: risk management in projects will most likely demand the use of resources and may consume some of the project budget. We don't want to respond to risks that are highly unlikely to happen or have very small effects, so make sure you conduct proper risk ranking. This can be accomplished by justifying why you have given a particular score to a specific risk component. This will differentiate risk management from just arbitrary guessing. After risk assessment, we can rewrite our list of ranked risks and start looking for ways to control them. Controlling risks should be a fun exercise because you have the opportunity to be creative and select among different tools to control risks. There are 4 main tools for risk control. Can we eliminate the risk? We can do so by making it impossible to happen or ensuring that it will have no effect on the project. We can also opt to reduce the risk by decreasing its chance of happening or its severity. We can also transfer risks to others who can better deal with it for a fee. Or we can just accept the risk if we know we can do nothing about it. In the project book, I have given different examples of how we can select and apply these techniques. Selecting a controlling strategy will depend on many factors, like the score of the risk, the importance of the project, and our ability to actually implement the control option. Okay, enough with the negative things for now. Life is fair, and if you must expect risks to be present in your project, you can also expect some opportunities. Opportunities are unexpected good things that can happen to your project. One would be finishing some tasks earlier than planned and reducing the cost of performing others. Similar, but opposite to identifying risks, project managers should also be able to identify opportunities, rank them, and try to get them to happen as much as possible. Risk management is a beautiful thing. It can act as a magnet and pull the different components of your project together, so make sure you apply it in your projects.
When the impact or the amount of damage is relatively lower, there are 2 ways to deal with this risk. If it is not likely that this risk may occur, so no probability, low impact, we can accept this risk. Don't care. If it happened, it happened, and it won't kill anyone, and the probability is also very low, doesn't matter. But if the probability of occurrence is high, while the impact is still low, we can try to reduce its occurrence. For example, do some precautions, try to avoid it from happening, and even though it happened, fine, the impact is still low. However, when we are going to deal with those scenarios where the damage is high, the impact is high, then we need to share those risks. If the occurrence probability is low, for example, we can buy insurance. Let's say if we take a flight from Hong Kong to London, although the probability of an aircraft accident is relatively low, but if it happens, then I'm afraid that those passengers may be killed. So we need to buy insurance to share the risk with the insurance company. If the impact is high and also the probability of occurrence is also high, we need to avoid those dangerous activities. However, in the risk probability chart, we divide the chart into 4 quadrants, and there may be some problem arise. For example, if you have a case where the probability of occurrence is 49% and the impact is also 49%. So this is considered as a low damage and with low probability. So you can accept this risk. But what if, in another case, the probability of occurrence is 51% and the impact is also 51%, just 2% more? Then it will fall into these quadrants that you should avoid because the probability is considered as high, higher than 50, and also the damage is also high. So this 2% difference will make a big difference. So is it fair? Or are there any ways that we can do this analysis in a more quantitative way? And as engineers, there are many different types of risks that we may encounter in a career. Technically, let's say electrical engineering, in a nuclear power plant or the fossil fuel power plant, there may be a risk that may even kill the workers. So this type of risk cannot be classified as simple as high or low, whether avoid or accept. We should make use of some quantitative means to measure the weighted consequence of this risk. There's a more sophisticated way to identify those risks by first rating the risk level from 1 to 10. So we can have an impact level from 1 to 10 and the probability level from 1 to 10. So in this green region, where the impact is either low or the probability is low, so this is considered as the green regions, not too risky. So in the yellow region, either the probability is high or the impact is medium or vice versa. So we need to pay attention to these regions. And in the red regions, where the probability and also the impact is also high. So this area we have to pay extra cautions. So if let's say there are two projects, project A and project B, now you can see there are many possible risks in project A. If you count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Probably the number of incidents may be more in project A than in project B. You can see the number of costs here. Each cost represents a risk. So in project B, you can see the number of costs here, which represent the risk, is less than project A. Does it imply that it is more risky for us to take project A than project B? Yes or no? Okay, we need to calculate the weighted risk, which is defined as a summation of the impact multiplied by the probability. So we add up the impact multiplied by the probability of each of these incidents, and then we can find out the total risk that these projects may expose to. Or we can put in a dollar sign and calculate the expected monetary values of the projects. So this expected monetary values is equals to the probability multiplied by the impact, and this impact is the financial costs of those incidents. For example, in the mountain, the high wind speed may probably damage the equipment, and it spent us 40,000 to replace the equipment, and the probability of this occurrence is 35%. And then landslide may be another natural disaster that may cause another 175,000, and the probability is not that many, it's only 5%. But on the other hand, in the mountain, there may be another positive risk, which is uncertain. The probability is 50%, and the impact is that 800,000 equivalent values of electricity can be generated, so that we can save the battery costs. So sometimes the risk may also be positive and bring in positive effect, and with a probability. Not certain. Anything not certain is called risk. And also there may be a risk that the track rental is unavailable, and then it will cost us $350, and the probability is 10%. So we can multiply this number together. For the risk number 1, 2, and 4, these are negative because extra cost has to be spent to rectify those problems. And for risk number 3, is the extra wind power generated from the generator will bring us a positive value of 800,000 multiplied by 50% of probability. So the weighted contributions by this risk is positive 120. So when we add them together, we will expose to a risk of negative $30.7. So in other words, the expected loss in this project is this value. But it doesn't mean that it's confined to this value. The worst case is you add up this loss, 16.8, 37.5, and $25. This will be the total risk. And the best case is that this risk number 1, 2, and 4 doesn't occur, but risk number 3 occur. Okay, then congratulations, you will earn 120,000 in this project. So there are many risks in the project, and in this example there are 4, but in general you need to add up all the possible risks multiplied by the probability of occurrence, then you can find the expected monetary value of the project. And also you can make use of the risk probability chart to prioritize the risk. What risk that you can accept, what risk you can ignore, and you need to focus on those risks with middle and high priorities. So you need to pay attention to those risks in this red or yellow region. And very often, risks also associate with the return. In the real life, when you take a high risk, usually you get a high return. If you do not want to take any risk, then you will have less return. Just like putting your money in the bank, and you will earn 0.1% or even 0% of interest rate, very low return. Or if you put money in the stock market, very stormy, on one day you may earn 20%, but on another you may lose 50%. So this is real life. Although sometimes there are risks with high risk and no return, but probably nobody would like to take it, right? And there may be, in some case, high return but no risk. This is too good to be true. Inform me if you have these kinds of investment opportunity. I can invest $1 and then get 1 million without any risk. Okay, this is too good. Therefore, we can also draw a chart to link risk and return together. So this chart shows the relationship between the risk and return. When you take an investment initially with low risk and no return, so you increase the level of risk that you can take, and then you will increase the level of return. For example, instead of just putting your money in the saving account, you put the money in the time deposit so that you can earn more reward, more interest rate. But at the same time, your money is locked up in the bank for a longer period of time, so you are taking higher risk. And if you want to be more aggressive, then maybe you can draw your money out and then put in the stock market. So the reward in terms of the investment return may be even higher, but the risk is also higher. So you may then enter from a low return range to an optimum return range. So if you continue to take this risk, let's say borrow money from the bank, take margins, and then buy the options and warrants, these are the investment strategies are more risky but with more return. Then your return rate will go up but then slow down the growth rate. But at the same time, your risk is also going up more quickly until a time when your risk exceeds your return. This is the point where you should stop. But if you think that investing in the stock market is still not fast enough, you can draw your money and then put in a casino and pay again. Probably if you win, then you can have 100% return. Or otherwise, if you lost, you will have 0 return. You lost everything. In this case, the risk exposure is too high than the possible return. And this is something that you should avoid. So today you learned how to make use of this risk probability chart and the risk reward chart to help you to analyze whether you can take what level of risk, and also learn how to calculate the expected monetary values of the project, which is a very important information for you to make a decision whether to go ahead the project or not.